This is free response question 5 from the 2024 AP Calc AB exam. This is part of the no calculator section. Consider the curve defined by the equation x squared plus 3y plus 2y squared equals 48. It can be shown that dy dx equals negative 2x over 3 plus 4y. Part A says there is a point on the curve near 2, 4 with x coordinate 3. Use the line tangent to the curve at 2, 4 to approximate the y coordinate of this point. So in order to approximate the value of the function, the y coordinate, at x equals 3, we'll find the line tangent to the curve at this given point, 2, 4, and then we'll just plug x equals 3 into the tangent line. So for our tangent line, we will have y minus the y coordinate, which is 4, equals the slope, and we can find the slope by plugging this point 2, 4 into the given derivative expression. So I'll just put parentheses there and we'll come back to that. The slope will be multiplied by x minus the x coordinate, which is 2. We are just using this given point of 2, 4 to construct a tangent line, and we'll use that to approximate the y value when x equals 3. All right, now for the slope, we will plug 2, 4 into the derivative. So that's going to be negative 2 times x is 2. And then this is divided by 3 plus 4y. So 3 plus 4 times y, and at x equals 2, we have that y equals 4. So then just doing the evaluation here, negative 2 times 2 is negative 4, and 3 plus 4 times 4 is 19. So that is our slope. Let's go ahead and plug that in, negative 4 over 19. So here is the equation of the tangent line. We think of this as the linearization of the function at x equals 2. And it can be used to get a decent approximation of points near 2, 4. So we'll plug in x equals 3. Plugging in x equals 3 to our tangent line equation, we have y minus 4 equals negative 4 over 19, that's the slope, multiplied by x minus 2. But x is 3, so that's 3 minus 2. So then we'll add 4 to both sides, so y equals 4, and then 3 minus 2 is 1, times negative 4 over 19 is negative 4 over 19. So this is just 4 minus 4 over 19. And that is the approximate value of y, which we could combine into a single fraction if we like. Getting common denominators and subtracting, this is 72 over 19. So this is the approximate y value of the curve when x is equal to 3. Moving on to part B. Is the horizontal line y equals 1 tangent to the curve? And give a reason for our answer. If this horizontal line was tangent to the curve, then the derivative, when y equals 1, would have to be 0. If we look at the derivative and ask when it could possibly be 0, well, for this to be 0, the numerator has to be 0, and for the numerator to be 0, x has to be 0. So the slope of the curve is only 0 when x is 0. That means that if this horizontal line, y equals 1, is in fact tangent to the curve, then it must be that when y equals 1, x is equal to 0. Because when x equals 0, the slope is horizontal, or the slope is 0, so the tangent is horizontal. So let's plug in x equals 0 and y equals 1 into the equation and see if it satisfies the equation. We have x squared, which is 0 squared, plus 3y, so 3 times 1, plus 2y squared, so plus 2 times 1 squared, and this equals 48. Let's check if it actually does. If it does indeed equal 48, then yes, the horizontal line, y equals 1, is tangent to the curve. But we see, doing the math, this is 3 plus 2, which is 5, and oh, that is not equal to 48. So in fact, the point 0, 1 is not on the curve, and it's only when x equals 0 that the slope could be 0, and thus the tangent could be horizontal. Since this point isn't on the curve, it's not possible that the horizontal line, y equals 1, is tangent to the curve. So we could say the horizontal line, y equals 1, isn't tangent to the curve because the curve doesn't have a slope of 0 when y equals 1. When y equals 1, we see that x can't be 0. This point is not on the curve. And since x can't be 0, the slope can't be 0, so not a horizontal tangent. All right, let's move on to part C. The curve intersects the positive x-axis at the point root 48, 0. Is the line tangent to the curve at this point vertical? And give a reason for our answer. So we'll have to see what the slope of the curve is at this point, and if the slope is undefined, some finite number over 0, then the tangent would be vertical. So let's check. So for part C, we will plug the given point, which is root 48, 0, into this expression for the derivative, and check if it's undefined. Here's our point, here's our derivative. Let's go ahead and plug it in. dy dx equals, we're plugging the square root of 48 in for x, so in the numerator we have negative 2 times the square root of 48, and in the denominator we have 3 plus 4 times 0, so that's just 3. And this is not infinite. This is defined, it's just some finite number. So the tangent line is not vertical because the slope is just a finite number. And thus we could say, since dy dx is not undefined at this point, the tangent line is not vertical at that point. The tangent line, in fact, has a slope of this, whatever that number equals. All right, let's go ahead and finish with part D. For time t greater than or equal to 0, a particle is moving along another curve defined by this equation. At the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. So we might say that dy dt equals negative 2. At that instant, what is the rate of change of the x-coordinate of the particle's position with respect to time? So we're going to have to take the derivative of both sides of this equation. That's going to require implicit differentiation. We'll have some dy dt's and some dx dt's in there because x and y are both changing with respect to time. We know what dy dt is at the moment we're interested in. It's negative 2. And so then we'll just have to solve for dx dt. So we're interested in the instant where the particle's at the point 4, 2, and we know dy dt is negative 2 at that point. We're trying to find dx dt. Here is the equation of the curve. Let's go ahead and take the derivative on the left side and on the right side. On the left, we would have the derivative of y cubed, so that's 3y squared. And then don't forget the chain rule. We have to multiply also by dy dt. Y is changing with respect to time. Then for 2xy, we will need the product rule, f prime g plus g prime f. Let's say that f is 2x. So then f prime is going to be 2. Then don't forget we also have to multiply by dx dt. So 2 dx dt, that's f prime, and then multiply by g. Then we have to add g prime, that's going to be dy dt, multiplied by f, which is 2x. So dy dt times 2x. On the right, the derivative of the constant, 24, is 0. Now we can plug in the known information. We'll plug in the point we're interested in, 4, 2, and we'll replace dy dt with its value at that point, which is negative 2. Thus, we'll have 3 times y squared, but y is 2, so y squared is 4, multiplied by dy dt, but that's negative 2, and then plus 2 multiplied by, let's write y first, y we know is 2, so 2 times 2, and then dx dt, which we will be solving for, and then plus dy dt, which is negative 2, multiplied by 2x. X is 4, so 2x is 8, and this equals 0. Then we'll move all constants over to the right side. So on the left, we'll be left with 4 times dx dt. So 4 dx over dt. And then the constants on the right, well, let's see. This is negative 24. So on the right, it would be positive 24. And this is negative 16. So on the right, it would be positive 16. So we have 24 plus 16, and that is just 40. So 4 dx dt equals 40. Thus, dividing both sides by 4, we arrive at the answer. Dx dt, the rate of change of the particle's x position with respect to time, is equal to 40 divided by 4, or 10. And if you want to include units, we were not given a unit for the distance, but we were told that t is in seconds. So we would say units per second. So 10 units per second is the final answer for part D. And that completes our solution to free response question 5 from the 2024 AP Calc AB exam. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. If you want a little bit more practice, check out my 10-hour-long video of AP Calculus AB and BC FRQs, linked in the description as well. Thanks for watching. I'm the mathematical menace, the machinations of mankind, two calculators at the same time, hand signs and abacus, finger counting calculus. I'm the V to the T, my parameter the rapidest. Happens like this, my lectures the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need